Once we have declared our working folder and we know where the Microsoft Excel executable files are located, we can start a new instance of Digital Visual Fortran 6 to create a new project which will be of the dynamic link library kind. Our current desktop will be a location for our project, and our project name will be HK as we're going to program the Heidemann-Khalil algorithm. We say OK, and we say that an empty DLL application will do fine. In our project, we can add a new Fortran pre-format source file. We can name it any way we want. I'll name it code. Say OK. I'll close the workspace window as well as the output window, and I'll begin writing our subroutine HK. It can have the same name that our project. I know that I am typing it in the code F90 file. Its first argument will be a variable n. It will identify how many components will be present in the mixture. We also need a variable flag to identify which kind of calculation our subroutine will perform. The critical temperature, critical pressure, and eccentric factor as well as the composition will be passed by reference inside the mix variable. We need a matrix for the binary interaction parameter of the first parameter of our equation of state, and Cij for the second parameter of our equation of state. We need a temperature, a relative volume variable, and all of these will be the input variables to our function. The ones which will be calculated will be the pressure, the cubic term, and the Qig matrix, as it will be the Jacobian matrix for our Fugacity logarithm. It's a very good practice to include the implicit none sentence, so all of our variables will have a declared type. We also need to include a declaration which will set the attributes of this DLL to export our Heidemann and Khalil function. This will make it visible to any application that might call the function to our DLL. Next, we'll declare the type of our variables. Long integers will be n and flag, and real 8, which stands for double precision variables, will be the mixture matrix, which we can declare to have variable dimensions according to the number of components that we feed to our subroutine. And for each component it will have 4 properties, as we mentioned: critical temperature, critical pressure, eccentric factor, and composition. The binary interaction parameter is also a variable dimension matrix. The same for Cij. And in this same row we can insert an scalar declaration for temperature, another for relative volume, another for pressure, the cubic term, and Qig will be a matrix as well. We'll conclude the subroutine at this point. To know that to check that we are okay, we compile. It says 0 errors, no warnings, and we can save our project. And from the project settings menu we can choose as our executable for the debug session to be Microsoft Excel. We know where it's located thanks to that function. The name of the Excel application will be Excel. .exe. The working directory will be the current workspace folder, the debug folder inside it, and the program arguments will be to open a workbook with the same name as our project. We'll say OK, and we'll add the new Microsoft Excel workbook with the same name of our project, HK. We'll compile, build, and execute Microsoft Excel from our Digital Visual Fortran environment. We see that it opens the HK workbook, and this is the end of step 2.